Hello guys, in this video I'll talk about properties of determinants. Calculation of determinants by elementary operations on the columns. In this section you will see how to calculate the determinants of the matrices using elementary operations. Okay. Suppose we have an n times n matrix A and C1, C2 and so on Cn are the columns of this matrix. Okay, for the matrix A, I will use this notation. A is C1, C2, Ci, Cj, Cn. This, if we replace the i's column and j's column, then our new matrix will be this: C1, C2, Cj, Ci, Cn. This. For this matrix, I will use this notation: A prime. If we use this elementary operation, instead of Ci plus lambda Cj, then our new matrix will be this: C1, C2, Ci plus lambda Cj, Cj, Cn. This. For this matrix, I will use this notation: A2 prime. Okay, if we use this elementary operation instead of Ci, lambda Ci, then our new matrix will be this: C1, C2, lambda Ci, Cj, Cn. This. For this matrix, I will use the notation A3 prime. This. From the basic properties of the determinant, we know that the determinant of A prime will be minus the determinant of A. Here, the determinant of A2 prime will be the determinant of A. Here, the determinant of A3 prime will be lambda times the determinant of A. Then from here you see the determinant of A will be minus the determinant of A prime. Here determinant A will be the determinant of A2 prime. Here the determinant of A will be 1 over lambda determinant A3 prime. Then from here we obtain that if we use this elementary operation, then the determinant of A will be minus the determinant of new matrix. Second one, if we use this elementary operation, then the determinant of A will be the determinant of new matrix, A2 prime. If we use this elementary operation, instead of Ci, lambda Ci, then the determinant of A will be 1 over lambda, determinant of new matrix. Then, in order to calculate the determinants, we can use these elementary operations. Okay, let's look at an example. Exercise. Compute the determinant of A. Here, in order to calculate the determinant of A, I will use column elementary operations. Okay. Determinant A is the determinant of 0, 3, 2, 1, minus 6, 6, 5, 9, 1. This is equal to, here I will replace the first column and second column. It will be minus determinant 3 minus 6, 9, 0, 1, 5, 2, 6, 1. This. Here we use this property. You say determinant A is equal to minus determinant new matrix. Okay. Here I will use this elementary operation. Instead of first column, we write 1 over 3 times first column. Then it will be minus 1 times 3 times the determinant 1 minus 2, 3, 0, 1, 5, 2, 6, 1. This is equal to, here I will use this elementary operation. Instead of third column minus 2 times first column. You know, if we use this elementary operation, then the value of the determinant will not change. Because of this, we write minus 3 times the determinant of 1, 0, 0, minus 2, 1, 10, 3, 5, minus 5. This. Okay, this is equal to, here I will use this elementary operation. Instead of third column minus 10 times second column. Then in this case the value of the determinant will not change as well. It will be minus 3 times the determinant of 1, 0, 0, minus 2, 1, 0, 3, 5, minus 55. This. You see, this matrix is a triangular matrix. Because of this, it will be minus 3 times the product of diagonal terms. 1, 1, minus 55. This is equal to 165. That's all. Okay guys, let's look at the second property. Determinant of a product. Suppose we have two n by n matrices, A and B, then the determinant of A times B is equal to the determinant of A times the determinant of B. Third property, determinant of invertible matrices. Suppose we have an n times n matrix A, and this matrix is invertible. Then the determinant of inverse of A is equal to 1 over the determinant of A. Here in the second one, using the elementary operations over the columns, you can prove that it's true. Look at the third one, and using the second one, you can prove that this is also true. Okay, look at here. Suppose A is invertible matrix and the inverse of A is A minus 1. Then you know that the product of these matrices will be identity matrix, IN. From here, the determinant of A times the inverse of A is equal to the determinant of identity matrix is 1. You know the determinant of identity matrix is 1. Then using the second property, instead of this, we can write the determinant of A times the inverse of A is equal to the determinant of A times the determinant of the inverse of A is 1. From here, the determinant of inverse of A will be 1 over the determinant of A. That's all. Exercise. Suppose we have two matrices A and B. Compute the determinants of A, B, A times B, and the inverse of A. Let's find the determinant of A. Determinant of A will be, you see this matrix is a triangular matrix. Because of this, the result will be the product of diagonal elements A, B, C. That's it. Let's find the determinant of B. Determinant of B is determinant of 1, 0, 2, 0, D, 0, minus 2, 0, 1. Here I will use this elementary operation over the columns. Instead of first column plus 2 times third column. Then our determinant will be this. 5, 0, 2, 0, D, 0, 0, 0, 1. As you see, this matrix is a triangular matrix. Because of this, the determinant will be 5 times D times 1. Yes, 5D. This. Okay, let's calculate the determinant of A times B. Then you know it will be the determinant of A times the determinant of B is equal to ABC times 5D. This. That's all. 5ABCD. Then we find the determinant of inverse of A. You know this is equal to 1 over determinant of A is equal to 1 over ABC. Here we assume that A, B, and C are different from 0. Okay, that's all. Let's look at the force property. Determinant of the transpose. Suppose that we have an n by n matrix A, then the determinant of the transpose of A is equal to the determinant of A. This property is very important because it shows that in order to calculate the determinants, we can use not only column elementary operations but also row elementary operations. Okay. All properties on the columns of a matrix are also true when applied to rows. Therefore, to compute the determinant of a matrix A, it can be used Gauss method. Let's look at exercise. Calculate the determinant of A using Gauss algorithm. Okay. Determinant A is determinant 1, 0, 8, 3, 4, 20, 5, 6, 28. We will find the row echelon form of this matrix using Gauss algorithm. But as you can see, our main goal is to find the determinant of this matrix. Because of this, here you don't need to write the steps of algorithm. Okay. You see first element is different from 0. First I will try to cancel the first elements of second row and third row. Because of this I will use these elementary operations. Instead of second row minus 3 times first row, and instead of third row minus 5 times first row. Then the value of the determinant will not change. It will be this. determinant 1, 0, 8, 4, 4 minus 4, 0, 6, minus 12. This one. Then we cancel 6 in the third row. Because of this, we use this elementary operation. Instead of third row, we write 3 over 2 second row. When we apply this elementary operation, then the value of the determinant will not change. Because of this, it will be determinant 1, 0, 8, 0, 4 minus 4, 0, 0 minus 6. You see this matrix is in row echelon form. And also it's a triangular matrix. Because of this determinant will be this one. 1 times 4 times minus 6. The product of diagonal terms. It will be minus 24. That's all. See you guys next lesson.